So what we're going to do here today is we are going to take a look at some more histograms and bar graph stuff quickly, but then we're going to jump into two-way frequency tables. Oops, I'm way zoomed in. There we go. Two-way frequency tables. And we'll discuss those two. All right, but first let's briefly review the histogram stuff versus bar graphs. Okay, so how are histograms different from bar graphs? Okay, so yeah, John, you want to go ahead?
On the x-axis, there are different ranges instead of single values.
Okay, so you're saying like a histogram. So which one has the range of values?
The histogram.
Histograms have a range of values that we're covering, whereas a bar graph will be like individual kind of values. Okay, is that what you're going to say too there, Alex? Something like that? Yeah. Also, bar graphs tend to compare different things. Okay, so not like categories of things, but different things. So for example, you use a histogram in this case because these are like age ranges and it's people here, right? All these are just people with different ages and stuff like that. But you might use a bar graph, for example, if I gave you a pack of M&Ms and I wanted you to compare the number of reds versus greens versus blues versus browns and stuff like that. That'd be a bar graph because those are all kind of like individual different kind of colors. Whereas here, we're all talking about people. It's just where their ages fit in. And of course, then there's also ranges, right? You wouldn't do like a range of colors on a bar graph or range on a bar graph, okay? So yeah, so histograms organize data into categories or ranges, we'll say. Bar graphs graph individual I don't know, individual quantities, I guess we'll say, or something like that. So, what should be considered when determining the ranges for histograms? So that's just it, right? There's no like rule for how big your range is for a histogram. You can have as many, you can make your ranges as wide as you want. So for example here, we could have made one gigantic range from 0 to 100, for example, or 0 to 500 or something, And so we'd have just one giant bar with all of our data points in it. But of course, you don't want to have just one giant bar because then we're not comparing it to anything here. So how can we kind of consider, the ranges for our histograms here? What do we want to look at when we're trying to consider how wide to make the ranges for our bars and stuff like that? Any ideas here? What should we consider? What should we look at? Yeah, what we're talking about, the kind of data that we're dealing with, right? So in this case, we're dealing with age ranges, right? So it wouldn't make sense, it would not make sense if we're talking about an age range to have the width of my, range be like 100, right? Because, well, that's going to cover pretty much everyone, has an age between 0 and 100, right? There's a few people that are outside that range, okay? But it's rare, right? So you want to be careful what you're talking about. On the other hand, right, if you're talking about, number of bacteria on any one of your desks, right? 0 to 100, probably too small of a number, right, for an individual thing. Okay, there's probably millions of bacteria on your desks right now. Something to think about. Okay. Sometimes I see students put like apples on their desks and then pick them back up and bite into them. I'm like, all right, you just tasted what everyone else has been doing on your desk since before you put your apple there, but okay, that sounds good. Anyway, so helps. I guess what doesn't kill you makes you stronger, right? Except for like paralysis and stuff. That's not really. But anyway, you get the idea. What should be considered when determining the ranges for histograms? So it's the data. Okay, the data and how spread out it is. Okay. In this case, we already have our categories picked for us, and we already know how many people fit in each category. So that's super nice. All right, now when we go to graph over here, though, right, we're going to want to label our axes here. So let's worry about our y-axis here first. Okay, our y-axis, what's the highest y value that we need to have on our y-axis? 12. So what should we maybe count by over here? Ones is probably going to be okay. Yeah, so let's just count by one. So I'm going to skip every, so I'll do like 2 there, and then 4 here, 5, 6, 7, 8. I'm only going to label every other one just because it's going to be a little too smushed otherwise. We also should label our y-axis here and call that the amount of people. Okay. Well, I should probably zoom in some more. Let me just do this. Okay, amount of people. And then the x-axis, what will its label be? Age range. You got it. Ooh, I didn't leave myself very much space there. Okay. Okay, now for this, you can kind of make your bars as wide as you want to. So I don't know, maybe I'll make each bar like 3. Let's see, we need to have 1, 2, 3, 4, 5, 6, 7. Yeah, okay. So I think if I go, let's just do 2 at a time. So I'll like, there's a bar, there's a bar, there's one, there's one, there's one, there's one. So 1, 2, 3, 4, 5, 6, and then 7. Okay, and then in each bar I'm going to put like 0 to 10, 11 to 20, 21 to 30, 31 to 40. I should have written my age thing down lower because this is like way too smashed together. 61 plus. Okay. This is also not super great here because most of these categories have a 10-year range, but then that last category, well, I mean, there's probably like, you know, a 40-year range in there, right? Or even more, 40-plus year range in there. So it's not the best, but anyway, we'll do with what we got. All right, so now we'll just make our bars. All right, for the histogram. So 5 is the highest. We're going to go here. So 5 right there. Okay. And then 4 for 11 to 20. So there's 4 right there, 11 to 20. Okay. And then 21 to 30 is 10. So okay, like that. And then 12 for 31 to 40. And then 7. Okay, and then 8. And then 3. And there's our histogram. But Mr. Witt, I see bars, right? You're right, okay? And it's a graph, right? You're right, but it's not a bar graph, it's a histogram. The categories, the age ranges there, that's what makes this thing a histogram. Bar graphs would be like if you're comparing, you know, like I said, the easiest one I can come up with is like M&Ms, right? If you had a bag of M&Ms and you said there were 3 blue, there were 4 green, you know, like that kind of thing. That would be a more bar graph kind of data, okay? Individual different categories, you know, individual kind of categories there as opposed to ranges. Okay? Questions on any of that? All right, I'll put my names right there now. So that's all I'm going to say about histograms. Now we're going to jump into these two-way frequency tables. All right? And these, I apologize, they are like super squished in there. Okay, so we're gonna I'm gonna zoom in, and it's gonna be probably hard to read on my paper. Might be even hard to read on your paper, but hopefully not. Y'all have young eyes, right? Although some of you might be farsighted, in which case you have trouble seeing things that are close up here. So anyway, we'll see. So let's take a look here at these two-way frequency tables. Okay. So on the bottom left of the paper here, there's our histogram. We're gonna go right down to here. Okay, and just introduce these two-way frequency tables. Okay? So a frequency, right? What does the word frequency mean? It just means how often something occurs, right? How often something occurs, right? If you say something happens frequently, right, that means it occurs more often than not, kind of thing. Okay? The two-way part of this frequency table is that you talk about frequencies across, okay? You talk about frequencies across here. So like we have males that, you know, with sport utility vehicles, males with sport cars, and the totals. We also have females with sport utility vehicles and females with sports cars, okay? But then you also have, you can go this direction too and say, okay, sport utility vehicles owned by males and females and the total, sports cars owned by males and females, and there's the totals and stuff too. And then you have the grand total right here in the bottom right corner that gives you the total males and females together, or as well as the total sports utility and sports cars together there for this particular survey or whatever. Okay. So there's names for these different cells, and I use the word cells there because it's like you know, you guys think about like a spreadsheet or Excel, right? A cell is like an individual part of our table here. So these 4 cells here on the interior, these are called joint frequencies, okay? Joint frequencies. Joint meaning to be joined together, right? Okay, so like this is the joint frequency of males who also have a sport utility vehicle, right? 45 is the number of females that also have a sports car, right? Joint together frequency, okay? The total number for 2 things together, okay? Joined together there. The marginal frequency, okay? Well, think about like the margins of your paper. Those are like the edges of your paper, right? The marginal frequency are the frequencies on the edges here, okay? On the outside, okay? If, you know, a group is considered to be on the margins of society, that means they're kind of like on the outside of society, right? They're kind of like a fringe group or something like that too, right? You might use that in that sense, okay? So anyway, joint frequencies on the inside for the, you know, paired frequencies there, but then marginal on the outside there, okay? So let's scoot over here to this side then. So here's how we can use this kind of information, okay? So we can answer a variety of questions using these two-way frequency tables. So I'm going to zoom in specifically on this left one first, and then we'll talk about the right one there. Okay? So again, it's the same table we just talked about here. It's just even more squished because why not? No, actually, just so we can fit more stuff on the page here. So, you know, the first thing asked, how many people responded to the survey? Right? Well, how many people? That's our total right there, 240 people. Right? How many males responded to the survey? Well, there were 21 males that had the sport utility and 39 that had a sports car, and so therefore there was a total of 60 males that responded, right? How many people chose an SUV? Well, total people, males, 21 males, 135 females, for a total of 156 people chose SUVs, right? How many females chose a sports car? 45, right? So female sports car, right? That's that joint frequency there, 45. How many males chose an SUV? So again, joint frequency there, male SUV, 21, right? Just easy to answer those questions. Now, in addition to a frequency table, which tells us the number of people, we also have something called the two-way relative frequency table, which is basically like probabilities. So you can see here, what we do is that 21 joint frequency, we put that over the total number of 240, so 21 divided by 240, and that percent, that decimal gives us the percent, or the probability of a male liking a sport utility vehicle based, or wanting a sport utility vehicle based off of the data here, okay? And so you see all these different little percents. They're all out of 240 because that's the total number of people that took the survey. Okay, they're all out of 240, okay? So you can say, okay, what percentage of the survey taken was female? Well, let's see here. Females, there were 180 out of 240, so that percentage is, goodness, I think, what does it say, 75%? Yeah, 0.75, so 75%. What's the relative frequency of males choosing a sports car? So again, what's the frequency of male? Relative means the percent. Males choosing a sports car. So male sports car, 39 out of 240, or 0.16, 16%. Was there a higher percentage of males or females choosing an SUV? Okay, well, what percentage of males chose an SUV? 9%. And females that chose an SUV, 56%. Okay? All right. So anyway, there's that. All right. Now, yeah. All right. So anyway, the two-way frequency table is showing soft drink preferences. All right. So let's complete this one. All right. So again, we've got things broken down into boys and girls here. All right. We have then people's preferences for soft drinks. So we have Coke, Pepsi, and then other. All right. So let's come up with our totals here. So for this total here, what are we going to add up? To complete this total right here for this cell, what do we add up? Which numbers? Tell me the numbers. Sorry. 15, 6, and 1. Yeah, the Coke, Pepsi, and other, right? So 15 and 6 makes 21, plus 1 is 22. Okay? How about for girls? We do the same thing, right? 12 and 7 is 19, plus 9 is 28. Okay? And then you can also add these up, these other marginal frequencies as well. So 15 and 12, 27, and then 13, and then 10. So how many total people are we talking about here? Well, 22 plus 28, that's 50, but 27 plus 13 and 10, that's also 50, right? So both this way and this way should add up to your total there of 50. Okay? So there's our frequency table, two ways, again, vertically, right, or horizontally there. Now we're going to create a two-way relative frequency table. So that's where we're going to come up with the probabilities here. So boys who like Coke, right, how many boys liked Coke according to the table? 15 out of the what? Out of 50, right, out of a total of 50. So we're going to 15 out of 50, and in our calculators we will get the decimal there. Question?
Do you always need to add 50?
No. It's, in this case, because of the numbers, the way they work out, it's 50. You'll have to, for your case, it'll be different then. So we get 0.3, which is what percent?
30%.
30%. Very good. So, okay, so right, exactly. Since these are all out of 50, you could just double each one of these, and that'll give you the percent, too. So that's another way to do it if you want. You can just put 30% if you want to. Yeah, sure. Okay? So I'll do the first row here. So now Pepsi is 6 out of 50. Okay, which will be 0.12 or 12%. Okay, other is 1 out of 50, which is equal to 0.02 or 2%. And then the total, that'll be 22 out of 50, which is 0.44 or 44%. Okay, go ahead and fill out the rest of the two-way frequency table there. Relative frequency table. So go ahead and fill out the rest there. Remember, they're all going to be out of 50, and then just convert them to percents there. If you want to just give me the percents there, that's fine too. But I'm going to put the fractions and the percents. So go ahead and just fill the rest of that out. What was the last one? I'm sorry? Like for these two? It's these cells right here. 1 out of 50, which is equal to 0.02 or 2%. And then 22 out of 50, which is equal to 0.44, which is 44%. Mm-hmm. Because your glasses, right? Gotcha. I gotcha. Looks like you're getting a little bit of like drainage down in here too, so there's gonna be a little black eye there.
I can't really see. And my whole face hurts.
Sorry. Something to look at here too, as you're finishing filling things in, right? There are columns in the first table, just the regular frequency table, right? Those columns add up to the total at the bottom, right? So 15 and 12 is 27, 6 and 7 is 13, 1 and 9 is 10, 22 and 20 make 50, and then also, of course, our rows add up to our totals at the end too, right? Well, the same is true for these percents, right? 30% plus 12% plus 2% is 44%, right? So all these percents are going to add up in a similar fashion. So when you fill them all in, okay, you can see here, 30 and 24 make 54, 12 and 14 make 26, 2 and 18 make 20, 44 and 56 make 100, 30 and 12 and 2 make 44, we saw that, right? 24 and 14 and 18 make 56, 54 and 26 and 20 make, well, 100, right? So, all right. So there's our answers. Questions on those? We're going to answer some questions with these right now. So any questions on those? So far so good? Okay. So let's answer some of these questions here at the bottom. So number 32 asks, what is the joint relative frequency, okay, of the, so relative, that means the percent, right? Joint means, you know, two things together there. So joint relative frequency of the students surveyed who are girls and prefer Coke, right? So that really gives it away right there. Relative is the percent, girls who prefer Coke. What percent of girls prefer Coke according to this survey? 24%. All right, 33. If there are a total of 150 students surveyed, how many would be girls who prefer Coke? So, John, what do you say here? What's that? 36. Now, John, how'd you come up with that number?
Well, if there are 50 and there's 12, it's multiplied by 3.
Okay, right. So, if you look here, in the original survey, 50 students were surveyed, right? 50 total students were surveyed, right? Okay, but then if it says if a total of 150 were surveyed, well, that would be 3 times the amount, right? If we had a survey of 50, but then it be changed to a survey of 150, that would be 3 times the amount of students. So if our survey is, you know, a good predictor, then we would just take the number of girls that like Coke, preferred Coke, and triple it as well to 36. Okay, yep, that's one way to do it. You can also take the 24% there and multiply it by 150 as well. That's the percent of girls that prefer Coke. Okay, and then times 150. Okay, so 0.24 times 150 is also 36. I'm going to show you here. 0.24 times 150, 36. So that also works. All right. What is the marginal frequency? So just frequency, not relative frequency, so no percent here, just marginal frequency of students surveyed who prefer Pepsi. So marginal frequency of students surveyed who prefer Pepsi. Not 26. What's the marginal frequency? So not relative frequency, no percents, not relative frequency. What's the marginal frequency here for the students who prefer Pepsi? 13. Yeah, we're going to go and use this number right here. 13 students. Okay, so that includes any. So there are 13 total students that that preferred Pepsi. Okay. What is the conditional relative frequency? Okay, so again, relative, that means we're going to use a percent there. Okay, conditional means there is a condition here. In other words, there's well, anyway, you'll see what I'm talking about. That a student surveyed prefers other, given that the student was a boy. Okay, so in other words, we should only consider the boys here. And what is the percent chance that the boys would prefer other? So let's go back up here and see. How many total boys were surveyed in this particular survey? 22. So 22. So our denominator is going to be 22 now because we're given that the student was a boy. So that means we have to use only the boys here. How many of the boys, preferred other? 1. Just 1. So 1 out of 22 total, okay? So given that the student was a boy, that means there's only 22 students we're looking at here. We're looking at a smaller group in the population there, okay? 1 out of 22, which as a percent is like 0.045 repeating, which is then 4.545%. Okay. So, okay. All right. Other questions on any of that? Okay. Go ahead, Kaylee. All right, so that's the idea there. I'm going to give you one here to try on your own, and we'll go over here as a class. Alrighty. Here you go. Actually, let me do this. Here's what we're going to do. So Mr. Stever is going to pass around a paper here, okay, to everybody. I'm going to let you guys either choose to work on the paper if you want to, or if you don't want to work on the paper, I've got 3 quizzes for you to work on, okay? So let me show you those.